Hi, I'm Tom Rieger. I'm the Conversion Support Services Manager out of the Office of Strategic Initiatives at the Library of Congress. And in this segment, we're going to talk about digitization standards. You've already developed your project plan, and you've gone through and picked your equipment, and you're all set to get going imaging. There's one more piece to this puzzle, and that is your digitization standards. At what quality level are you expecting to achieve, and how are you going to make sure that you get that same quality day in and day out as you do your project? And that's where this piece of the puzzle comes in. Okay? As a part of my role here at the Library of Congress, I coordinate the activities of the Still Imaging Workgroup of the federal agency's Digitization Guidelines Initiative. Now, what's that? That is I guess at this point, a 15-year effort to standardize the quality expectations of digitization units throughout the federal government, and that has extended itself to be cultural heritage institutions worldwide. So why has it become so popular? And the reason for that is, the reason it's become popular is that it's really been the first effort to provide a set of meaningful standards and ways of measuring those results, measuring compliance to those standards in a way that, that actually works. So this joint effort of multiple agencies of the federal government to contribute to finding a way of doing this has resulted in the original FADGI guidelines, which were issued in 2010, and now the new revisions to these documents that are going to be hopefully published in January of 2016. They'll be released for public comment, meaning you can start using them in a beta format, hopefully in mid-September of this year, probably before this gets released. So what are we talking about with measuring and monitoring of digitization quality? Well, it all starts with setting up your device. And for that, well, let's start even a little bit earlier. Before you can even set the device up, you need to calibrate it for color, which means imaging something like this and running the resulting images through a program that creates a color profile for you to get the best color you can out of your equipment. Now, chances are, out of the box, your camera or scanner is going to do a pretty good job. Most of them do today. But if you do the work of doing a profile, a custom profile, you will achieve much better results. Generally speaking, we're able to achieve what they call deltas, and a delta is one visible change from 1 to 2 and from 2 to 3. We're able to achieve results that are within 3 deltas of any given metric that we measure. That's really good. If you can get to that, then the work that you're doing is going to be reasonably close to the work that anyone else is doing around the country and around the world on similar materials. And it's important, it's very important that what we do or what you do is comparable to what other people are doing. If the color and the density is widely different between institutions, we no longer have a way of comparing what you do against what we do 50 years, 100 years from now. We'll have lost that context. We won't know what that object looked like. So establishing that color profile is key for that. Now, once you've established the profile, you need to move to another target, which we call a device level target. This is an example of one here. Now, what does this measure? It does measure the color based on these, but it's not building a profile. It's just measuring against the profile to see that things are as you expect them to be based on that profile. It's also measuring the density from light to dark. Are you capturing the entire range, and does the distribution of those tones from light to dark look correct, which may or may not be the case. So we do that. But probably most importantly here, we're looking at the evenness across the field. You see all these gray patches that are everywhere. Well, we know the values of those, and the software does. So we can tell how even your imaging is. And then you can tell by these funny off angle boxes, those are what we call slant edge targets, and we can measure the resolution of your imaging based on that. That's an ISO, International Standards Organization, method of measuring resolution. Now, and if you don't like that, there's actually visible, eye-readable targets in there to measure the resolution, and occasionally we'll refer to those. So targets like this, and there's a few different ones on the market, will give you very consistent readings of how your digitization system is working. And we measure these, we photograph these and we measure them at every operator shift, meaning the beginning of each day. And if the operators change at lunchtime or whatnot, we'll shoot another one of these. And my team within the library will read these and keep track of them over time to make sure that all the systems that we work with are staying within a narrow range of each other. So if you're doing small-scale digitization, you may be tempted to not do this. I would really hope that you would, at least at some level, whether you use this or something else, do something that you can judge the consistency of your imaging from start to finish with. Now, beyond that, within each frame, every image, we generally try to put what we call an image level target. This is just a smaller version of the same thing. It's not as good, it's not as robust, it doesn't tell us evenness across the field and things like that, but this will tell us image to image variability within a shoot run. So if stuff starts drifting all over the place, we know from this that that's what happened. So let me take you through the software that we use to do this. Now let me explain, before I do that this software has been developed over the last 10 years by the federal agency's Digitization Guidelines Initiative, which we call FADGI, because saying it's just too much of a mouthful. So FADGI has contracted with Image Science Associates to create this software over the last 8 to 10 years. And it's important in that this software has been very well thought out to measure the most important parameters that we need to know for digitization activities. And we don't measure things that aren't that important. So it's been refined for cultural heritage imaging. So if you can see it, and you may not be able to, and I understand we'll mix in some screenshots, but what's up there is a photographed image of one of these targets. And the way we would work this is we would go and select, I'm doing this all upside down and backwards, so it's a little bit tricky, but we would select, I'm going to get around here and do it. We would select the corners. Come on. It's not going to let me do it. All right. Well, in any case, we would select the 4 corners of that target and hit run. And it's not going to let me do this without, yeah, it's not behaving properly. But in any case, we would select run, and it would analyze all those various elements within a few seconds. Having done that, it'll tell us if it passes or fails the specific quality level that we've asked for. Now, this gets to the FADGI star system. We go from 1 star, meaning the lowest quality level that we measure, to 4 stars, which is the highest quality level reasonably obtainable today with the equipment that is available. Now, it's possible to image beyond 4 stars, that's a different subject, and it is necessary to do that at times for certain things, but the basic program is from 1 star to 4 star. Heroics are left for something else. So if we tell it that we want to measure against a 3-star standard, it'll come up with a little green box to say, okay, you're there. If you don't meet the standard, it'll come up with a red box that says fail. And then you can go in and you can look at the individual parameters to find out why. It's meant to be a quality check against your entire system, and it's not hard to pass these standards with good equipment. They're intentionally designed to work with the equipment we now have at the capabilities of those pieces of equipment. So we're we're not setting something up here that's an impossible dream. This works day in and day out at institutions all around the world every day. So that's how we measure quality.